taking the machine back, then you can switch off, or machine is also possible to calculate back whether you are going in the other direction, and then it is able to correct its location. So this type of thing is available in the machine. So overlap is not possible. Same location, if you are moving back and forth many times, machine is automatically able to correct it. So it doesn't give you number of defects, or it is overlapping the defect. Now what does the B scan show? B scan shows the depth and the orientation or defect within the rail. Basically, it also shows along the length of track, the location. So डेप्थ दे रहा है, ओरिएंटेशन दे रहा है, एंड लोकेशन दे रहा है. तो three important thing they are giving. Now at a time in machine, wherever you are able to see the B scan, you can see either A scan or B scan, and there is also facility of simultaneous representation of both A and B scan. So you can set whatever way you want. Now, see, this is a typical representation of a B scan display. Like, any question? Any question? Okay. So in here you will be having, this is the upper screen, which is A scan display, and the lower screen, this is the B scan display. So this is the mode when you are able to see both. But A scan, typically what I have shown you, the frozen thing is not visible here. It is showing individual peak. Right? But because it is continuously recording, and whenever peak is coming, it is possible for this machine to capture all those peaks, and it will be stored in the terms of data. So not in the terms of picture or image, in terms of data. So it is possible for you to select the particular, suppose you select this particular defect, and then after selection of this defect, it is possible for you to see the A scan as we have shown you earlier in that format. So based on that, it will give you this thing. Here you are able to get the complete detail, like what we have seen. This is all thing has been filled by the operator. What is the kilometer? What is the section? What is the rail detail? And then what is the probe used? Peak height, depth, all this detail it will be given. So that is possible for you to see. And see, here it is giving the latitude and longitude from which it is able to correlate the GPS thing. It is also giving you the kilometer and meter, and in terms of meter you see, so it gives you centimeter. So that is how this machine is able to capture much larger data, and it is possible for us to overlap the current run and previous run and see how it is increasing or decreasing. Now again come back to this. Here you can see this is the white signal. This white signal normally is set for the 0-degree probe, and 0-degree probe always shown at the bottom here in the foot region. So this is the 0-degree probe defects. Now here you can see there are certain regions where there is a no back echo. Certain region you can say there is a drop in the back echo. So as we know, no back echo and drop back in back echo results defects according to 0-degree probe. So that way it is possible for us to identify which location there is a problem. Now if we select this region, so we will able to get the larger image. Or see, suppose this is covering 5 kilometer range, and if you are selecting, so this may be about half a kilometer or 500 meter length, and accordingly you will able to find out what is the correct length where the problem is there. So you can identify, okay, this much length is there is a problem with the back wall echo. So if we are able to find out some reason why it is there, is there any lack of contact, where there is some other problem, or we can repeat it. So then we can very well classify that as this location there is a problem, and we can compare with respect to the previous also. We will find that previously there is no issue, this time only come, then means something wrong at the time of recording. We can check it up and then we can find it out. Similarly, you can see like this one is the red color. In the red, you see some peak has been shown here. Now, how this will be indicating what has been told you in the next slide is, in this slide, it is telling that it will show the depth, it will show the orientation and location. These three things it will show. Now, how it will showing it, again, we can understand. What does it mean by depth and orientation? See, you can see now you can see, suppose this is the rail head, and if the flaw is say oriented, say 20 degree, we are getting some and suppose the flaw is oriented perpendicular to this, like this. Now we also know, and again if you look in the plan, if you look from this side, then what will happen? Say this is the, for simplicity I'm making a square section, and here is the problem. So this is my whole area, whatever is being represented by right. Now suppose I am telling this is one ray come, I'll choose another color. Suppose one ray is coming and hitting one, this I will say 1. So what I understand, this is at the bottom of the flaw, so somewhere here it will be hitting. That means approximately this much of the area is reflecting the ultrasonic wave, and accordingly, and if the total area of the ultrasonic wave covered in this region is say this much, I can say this is covering say 25%. So if I draw the echo pattern, then you must also understand the distance traveled to go this much down. This distance, this beam path is bigger than this beam path. So what will happen? I am moving the probe in this direction. So I will get somewhere farther away from the origin. Say I will get, this is from the first peak, and it is having amplitude of say 25%. It is not exactly the area cover, but whatever amplitude is coming at, say, and I this location, then I can say the area covered is something this much, say 40%. So what will happen? The moment I come closer, I will get another peak of this area. So I can say this is 40%. So likewise, I will be keep on getting. Now, how it has been shown here, in this B scan, this one particular kilometer, I know the depth. What is this depth? What is this depth? So here it will make a point at this depth. then it will immediately make a closer point at this depth. Now you can see this is the horizontal separation of the each and every points. Similarly, when it comes to point number 1, 2, 3, 3 will come further here. Then point number 4, it will come further here. And then point number 5, it will come further here. So like that, it has taken some 4, 5 points, and each point has been separated at some distance. And every location, we know that depth is different. So that is how it is able to give me. Now, this thing is approximately matching with this orientation. So that is what we mean, that the B scan, we could able to see the orientation. We are really not seeing the actual flaw. We are seeing each and every signal. Now this signal will be stored with respect to this beam path and this amplitude or height, you say. So every signal I store V1, H1. Here V2, H2. Here V3, H3, and so on. So what is happening in this particular flaw region? There may be, say, hundreds of peak has been stored. So I will say the peak is stored from P1 to P100, and this is B1 to B100, and here H1 to H100. So this much detail has been stored for this particular flaw. Now if you will take all the flaw, then it is possible for you to reconfigure this defect. And now it will show you this is the A scan. Now from this A scan, depending upon the B, whenever we know B, it is possible for me to find out this location where it is B1 located and where the B100 is located. According to B1 to B100, I will able to find out the movement of the peak on the horizontal scale, and from this, whatever is the maximum is. So this I will pick it up. Now this thing is giving me the A scan thing. So that is how from the B scan we can regenerate A scan, and then we will able to classify the defects. ये कुछ समझ में आया थोड़ा?
Yes, sir.
क्योंकि अभी आप लोगों को ई स्कैन मशीन इतनी ज्यादा देखने को नहीं मिलेंगी, ये थोड़ा सा कंसेप्ट देने की कोशिश किया आपको. ये यहाँ पे अब आप देख रहे हो, यू कैन सी द वेरियस ये जैसे आपको ये ओरिएंटेशन दिखाई दिया डिफेक्ट का, दूसरा ये ओरिएंटेशन दिख रहा है, ये दिख रहा है, ये तरह तरह डिफेक्ट के ओरिएंटेशन दिख रहे हैं. इट इज नॉट एग्जैक्टली द ओरिएंटेशन ऑफ द डिफेक्ट. Defect is varying. So you can say typically it is a collection of B scan is nothing but the collection of so many number of points from where we are having the beam path and the height. And once we know the beam path, we know the angle of the probe, we can always reconstruct the A scan. And once we are able to reconstruct the A scan, it is possible for us to define it. In this picture again, the defect has been shown with respect to the various location, like that every amplitude it is lengthwise it is traveling, it is able to find the various number of points. Here typical animation we are trying to make it. So like you can see this defect. So this defect initiated collected and then now gone. Similarly, this was earlier captured, which is gone. So you cannot see whatever signal is seen here, and the same signal is giving just below that. So this scale is different, this scale is different. This scale is in terms of kilometer. This scale is in terms of beam path. तो ये दोनों स्केल अलग अलग हैं. यहाँ पे डिफेक्ट दिख रहा है तो नीचे नहीं आएगा. ओके, एंड इफ यू आर सीइंग दिस डिफेक्ट, दैट मींस दिस डिफेक्ट इज लॉन्ग बैक. मे बी यहाँ से यहाँ के बीच में 200 मीटर का अंतर होगा. ओके, सो दैट थिंग वी हैव टू अप्रिशिएट. उसके डिफेक्ट के नीचे ही हमें बी स्कैन नहीं मिलता है. ये वेरियस डिफेक्ट इस तरह से आएंगे एंड चलते चले जाएंगे. लाइक दैट वी विल एबल टू फाइंड आउट द. अब इसमें यहाँ पे एक पर्टिकुलर डिफेक्ट दिखाया गया है with respect to orientation, other thing it is possible for you to find out. और इसमें सारा डिटेल दिखा रहे हैं कि इसका साइज क्या है, पीक हाइट क्या है, हॉरिजॉन्टल मूवमेंट क्या है, कौन सा प्रोब यूज किया है, एंड अकॉर्डिंगली इट इज पॉसिबल फॉर अस टू फाइंड आउट और क्लासिफाई इट. I hope and I don't know when the time will come you will able to use the machine yourself. So okay, so anything, any doubt or anything you wanted?